Okay, today we're going to have a look at multiplying rationals. And to establish where we're going to go to, I just want to, we are going to work towards establishing a rationale for why we multiply rationals the way we do. Now, we begin with the fact that whenever you multiply any two things, say you have two sets of 3. Any multiplication situation can be modeled as an array. I've got one set of 3 and a second set of 3 will give me my two sets of 3, which we know equals 6. So the point is, every multiplication problem can be represented as an array. An array is just like an area model. It's a method to establish multiplication. Now, let's extend that idea to fractions. Let's say we have 2/3 of 4/5. So what I'm going to do is I'm going to, first of all, create a whole. This being the whole, and I'm going to take that whole and divide it into fifths. I hope these are relatively close to being looking equal. I have 5/5, which is the same as a whole. So I want to take 2/3 of those 4/5. So here are my 4/5. First of all, I'll just shade those in. Alright, so here is my 4/5. And if I take 2/3 of those, I'm going to take my whole, and on the other dimension I'm going to divide it into thirds. And I'm going to take 2/3 of the 4/5. This is the 4/5, and I'm going to take 2/3 of the 4/5. Okay, and when I look at that, I count up. I have my whole divided up into 15ths now, and I end up having 1, 2, 3, 4, 5, 6, 7, 8 15ths. So when we make use of the array, we can conclude that if I take this multiplication of fractions, in effect, I can perform it by multiplying the numerators. I get 8, multiplying the denominators, and I get 15. And that's basically where the rationale for multiplying fractions comes from. Of course, we could extend that same thing to, let's say we had 4/5 times whole number 2. Well, whole number 2 we're going to consider as a fraction, or put it in fractional form, as 2/1. So we're taking 4/5 of 2 wholes. Again, I can apply this multiplication rule to it, multiply the numerators, multiply the denominators, and express this improper fraction as an equivalent mixed number. Okay, so that kind of sets us up for doing a more elaborate, more complex multiplication of two rational numbers. Let's take 2.5 times 3/4. Now, first of all, recall back earlier grades, grade 3, grade 4, if we had something to this effect, 25 times 61. Basically, the way we went about that was we multiplied the 1s times the 1s, the 1s times the 10s. Moved over 1 and multiplied the 10s times the 1s, the 10s times the 10s. Well, we're going to do that in a similar fashion here. I'm going to arrange this multiplication statement vertically, so I have 2.5 times 1 3/4. So one way to perform this multiplication is as follows. 3/4 of 1/2, 3/4 times 1/2 gives me 3/8. 3/4 times whole number 2 gives me 6/4, or an equivalent form is 1 1/2. I move over to the whole number now. Whole number times the fraction. 1 times 1/2, or 1/2 of 1, gives me 1/2. And lastly, whole number times whole number gives me whole number 2. So when I take these add-ins and put them together, I have whole number 2 plus 1 is 3, 1/2 here and 1/2 here to give me another whole, which is 4, plus the 3/8, 4 and 3/8. Okay, so that's one method of multiplying rational numbers that happen to appear in mixed number form. Let's look at a second method of doing the same multiplication. I'm going to take 2.5 multiplied by 1 3/4, pardon me, 1 3/4, and I'm going to convert them to equivalent improper fractions. So this would be, 2.5 would be the same as 5/2. 2 wholes, each whole has a half, 2 halves, 2 halves plus 2 halves plus 1/2, 5/2. The 1 3/4, okay, the 1 whole has 4/4 plus the 3/4 gives me 7/4. The quick or algorithmic way is simply to go 4 times 1 plus 3 over your denominator. Now, we take the same situation, and all we've done is taken the mixed numbers and convert them to improper form. But we'll go ahead and multiply them as we would ordinarily multiply two common fractions. So multiplying the top times the top, we get 35. Numerator times numerator yields 35. Denominator times denominator yields 8. And if we convert that back into a mixed numeral, we get 4 and 3/8. And of course this has to be the same as that. So there are just two methods by which we can use to multiply rational numbers.